I've received some comments recently about enclosing electronic devices or building electronic devices into enclosures. Enclosures are, and have always been, one of the most difficult things to come by. Even in the late 60s, early 70s, anything very big almost required that you have access to a metal brake and a metal shear. Small boxes back in the 60s could be bought at Radio Shack. Metal, steel, and aluminum was cheap in those days. Today, however, things have changed entirely. So why am I holding what's marked 1-inch PVC Schedule 40? Appears to be pipe. It is pipe. You can buy this stuff at Lowe's or whatever your version of Lowe's is, in 5-foot lengths. It's easy to cut with a hacksaw. It files and drills like butter. 1-inch Schedule 40. The rest of these numbers are meaningless. We're talking about 1-inch nominal pipe. Schedule 40 gives the wall thickness. It's not 1-inch pipe. It's neither 1 inch on the inside or 1 inch on the outside, but this is what the world calls 1-inch pipe. Pipe comes in schedules from Schedule 10 to Schedule 160. Schedule 40 is the most common pipe of all. This is a bag. You can buy these at your local building store individually. It's a bag of 5 pipe caps, which are just what the name implies. They cap the open end of the pipe, and they fit over the outside of the pipe. Why, pray tell, am I doing all this? I've taken a piece of 1-inch pipe and I've cut with a saw an opening lengthwise. It's a little more than 3/4 of an inch wide. I've taken 2 end caps and I've cut them vertically with the saw so that these openings are a little more than 3/4 of an inch. I drilled a small hole here and a large hole here. I am going to test fit this frequency counter into my pipe. Pretty slick, huh? I'm going to temporarily fit the pipe cap with a small hole on here. I'm not going to glue it. I'm just going to push it in until it hits the stops. And I'm going to take the cap with the big hole and fit it here. Now what my intent is to fit a BNC connector through the big hole and connect it to the RF input of the counter. Then I'm going to take some sort of a wall wart and I'm going to insert it through this hole, tie a knot in the cord, and fasten it to the positive and negative power terminals. Alright, the wall wart cable is installed in the hole, fits pretty snug. Tied a knot in it, pull it down to its That's a good strain relief. That should work okay. In order to hold this display up from the bottom of the pipe, I just folded up some paper. Maybe not enough, but I'll insert the paper in. So there's 2 wads of paper jammed in here, one on either side of a header that I'm not using. Now this piece of pipe was cut 5 inches long, which is just a snatch over the length of the device. Now I didn't put the paper wadding clear out near the end because I want enough room to work these power and frequency input cables down inside the case, so that when I put the end on, which didn't work quite right, go down there, push the cables down, and there they go. Just slide this down enough to plug in the RF connector. I've put the BNC connector. Yeah, I know the polarity's backwards, but this end of the plug is opposite polarity. While thinking about things I could wad in lieu of paper, I have these big packing chips. But I'm afraid that the packing chips and the pipe and the sliding will result in static electricity. Here we'll tuck the RF connecting wires in, and then we'll put this cap on. And we have a bit of a rub there because I'm running into the connector, the RF connector, and the BNC connector is here. So a bit of poor engineering there, or poor planning. But it could be worse. Now if you want, you could secure these caps. I wouldn't glue them on. You may try putting a little dab of this silicone on the ends. Pull it out a little bit. I mean, we're not going to make it waterproof. We're just going to glue it, maybe. It's not like we're cleaning the pipe. Really, at the cost of these things, you probably could put a drop of super glue on here and say the hell with it. If it burns up, you could build a new one pretty quickly. Here's the completed gizmo. I have it hooked to a 2 megahertz function generator. I have no idea exactly what, well, this tells me 3,900 hertz high. I just turned the unit on and it seems to be slowly dropping. In a previous video, I hooked this to my 10 megahertz frequency standard, and it was stable as a rock. If I remember, I'll publish a link to that. Now, if you don't like this rolling around, glue a couple rubber feet on it. Not necessarily on the bottom. We have a round thing, so put 2 of them, for example, here and here, and it'll lay flat. But really, the stiffness of the coaxial cable keeps it wherever you want. I want to thank you for watching. If you enjoy this kind of stuff, please subscribe or drop me a comment or give me a thumbs up. Thank you.